Problem 6.9 asks a different type of question. Instead of being interested in a probability, where we're going to give our answer in terms of a percent, we're really interested in a number here. We want to know, on average, how many games will this tennis player play before he's expected to break a racket. In the problem, it states that he has a 15% chance of breaking a racket at any given match, and we're going to need to assume that rackets are independent of one another. So if a racket breaks quickly, the next one is not guaranteed to last longer, so they don't affect one another in that way. In order to assign digits, I'm going to show you how to use the random integer function on your calculator to do this. So I don't need to come up with anything fancy like I do for the random digit table. I'm just going to say 1 to 15 is that it breaks, and 16 to 100 is that it doesn't. And that's going to give us our total of 100%, where 15% of them are breaking a racket. In order to simulate these repetitions, I'm going to type the following into my calculator. I'm going to go to my random integer function. I want it to produce numbers between 1 and 100. And then I need to pick some number of them to occur. And I don't know how many I'm going to need. I could end there and then continue to just hit 1 and see how many times hit enter, see how many times it takes before I get something into the 1 to 15 category where it breaks. Or I could use my list to do this a little bit more efficiently. And that's what I'm going to choose to do. So I'm just going to ask it to produce 100 random integers. And I'm going to store that in list 1 so that it's easier to read. When I do that, I'm then going into my stat function, I'm looking at my list, and I want to see the types of numbers that show up. I'm going to start at the very, very top. So for me, the way my calculator is seated, I have 91, 69, 47, 15. And I'm really going to stop there for a minute because the first 3 numbers here are all kind of my good category. The racket hasn't broken, it hasn't broken, it hasn't broken. Now here at 15, the racket breaks. So this is one trial, and that trial tells me it took 4 games in order to break a racket. I'm going to continue on in my table now after 15 and see how many it takes the next time. So I get 95, so it's good the first game, good the second game at 84. Next game is 53, still going strong. Next game is 10. So kind of a coincidence here that it was another 4 games before it broke, because 10 falls in my category of where it will break. That's how we've assigned our digits. I'm going to continue on just to show you one more. So I get 80, 80 again. So a racket's good. It's still good at 39, still good at 85, 37, 86. So this one's lasting a little bit longer. 70, 92, 65, 16, still going, and then 11. So in this case, my third trial, it took me 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It took 11 games in order to get a racket that broke. So here are my 3 trials. I want to repeat this several more times to answer the question. In the end, we're going to take all of those numbers, and in order to state our conclusion, we're going to find the average of those numbers. So I'm just going to go ahead and do that for these 3. We had 4, 4, and 11. If we divide that by 3, we get 6.3 repeating. And so my conclusion would say that on average, it will take 6.3 or 6 1/3 games before Brian will break a racket. Again, you'd want to do more repetitions, but this at least gives you the idea.